So, good morning, students. We'll continue with topic number 7, which is earned value in a project, EV, resource aggregation, allocation, smoothing, and leveling. So, in continuation with our previous class, earned value in a project is a method that allows the project manager to measure the amount of work actually performed on a project beyond the basic review of cost and schedule reports. So EVA provides a method that permits the project to be measured by progress achieved. So the project manager is then able, using the progress measure, to forecast a project's total cost and date of completion based on trend analysis or application of the project's burn rate. So this method relies on a key measure known as the project's earned value. To report the accomplishments of the project, we must apply earned value EV to the figures and calculations in the project. So EV is the quantification of the work done till date. So in other words, EV, that is earned value, tells you in physical terms what the project has accomplished. So as with PV and AC, earned value can be presented in a cumulative and current fashion. Cumulative earned value is the sum of the budget for the activities accomplished to up to date. So current EV, that is current earned value, is the sum of the budget for the activities accomplished in a given period. Earned value is also called budgeted cost of work performed, which is BCWP. Next, planned value PV is determined by the cost and schedule baseline. Actual cost AC is determined by the actual cost incurred or spent on the project. So earned value EV tells us in physical terms what the project accomplishes. Next topic is resource aggregation, which is loading. So after each activity has been assigned its resources, the next step is to aggregate the resources used by all activities. Resource aggregation is simply the summation on a period-by-period basis of the resources required to complete all activities based on the resource allocation carried out previously. The results are usually shown graphically as a histogram chart, and such aggregation may be done on an hourly or daily or weekly basis depending upon the time unit used to allocate the resources. So when a bar chart is used, the resource aggregation is fairly simple and straightforward. So for a given bar chart, a resource aggregation chart can be drawn underneath the bar chart. However, a separate graph will be required for each resource type. So as I say this, you see the figure 6.2 resource aggregation. An example is shown in figure 6.2 where for a particular resource, the required resource units for each time period are written on the bar chart. The total number of resource units for each time period can then be summed and a resource aggregation or load chart can be produced as presented underneath the bar chart. Thus, having a project scheduling or planning is necessary to facilitate the bar chart drawing. The non-critical activities, activities which are not on the critical path, do not have any fixed starting and finishing times but are constrained by the earliest and latest starting and finishing times. This situation offers the planner the chance for adjusting the demand for resources. Figure 6.3, which is resource aggregation chart showing resource requirements associated with the earliest and latest times along with the highlighted resource requirements for critical activities. So figure 6.3 illustrates such situation which shows the resource aggregation when the activities scheduled or planned on the early times and late times. So it can be seen that the resource requirements that arise when both earliest and latest start times are considered different. So the shaded area represents the resources required by the critical activities as these activities have a fixed position because the early times equals their late time. Figure 6.3 also shows the accumulation of resources at the beginning of the project when the activity is planned on the early time. On the other hand, the resources accumulate at the end of the project when the activities are planned on their late times. Next, resource allocation. Resource allocation is also known as resource loading, and it is concerned with assigning the required number of resources identified for each activity in the plan. More than one type of resource may be assigned to a specific activity. For example, fixing steel plates on a bridge deck may require different types of resources such as welders, laborers, and a certain type of welding machine. From a practical view, resource allocation does not allow or does not follow a constant pattern, and some activities may initially require fewer resources but may require more of the same resources during the later stages of the project. Next, resource smoothing. So as shown in a previous figure, the problem of resource fluctuation appears after the initial planning of the project without considering the resources. So the peaks and valleys in the resource profile indicates high day-to-day variation in the resource demand. Resource smoothing is the process that attempts to determine a resource requirement that is smooth and where peaks and valleys are eliminated. For example, even if 7 units of a given resource are available at any one time, utilizing 5 of these units each week is preferable than using 4 units for the first week, 7 for the next, and 2 for the next previous, and so on. So even if there is no limit to the amount of any one resource available, it is still desirable that resource usage is as smooth as possible, given that the resource requirements of those activities on the critical path are fixed and some order or priority needs to be established for selecting which activity and which particular resource associated with this activity should be given priority in the smoothing process. Next, resource leveling. So a project is classified as a time constraint in situations where the project completion time cannot be delayed even if additional resources are required. However, the additional resource usage should be no more what is absolutely necessary. So accordingly, the primary focus for purposes of scheduling in time constraint projects is to improve resource utilization. This process is called resource leveling or smoothing. It applies when it is desired to reduce the hiring and firing of resources and to smooth the fluctuation in the daily demand of a resource as shown in a previous figure. So in this case, resources are not limited and project duration is not allowed to be delayed. The objective in this case is to shift non-critical activities of the original plan within their float time so that a better resource profile is achieved. Resource leveling heuristic shifts non-critical activities within their float times so as to move resources from the peak periods, that is high usage, to the valley periods, which is the low usage, without delaying the project, that is the area underneath the resource profile remains constant. Usually, project managers may prefer having a desired resource profile in which the resource usage starts with low values and then resources are built up till its maximum values and starts to decrease as the project approaches its end, as shown in figure 6.1. So, project time is constrained, resources are unconstrained, and objectives of even resources are usage. So you can give your attendance now in the chat box. Thank you.
Namaskar and welcome back to this series of lectures on principles of construction management. And in the last couple of lectures, we've been talking about planning and scheduling in construction projects. Today, we will concentrate on what is called resource leveling and allocation. Now, construction schedules, as we know, are either time-oriented or they can be resource-oriented. In our discussion so far, we have mostly talked about concepts related to time-oriented scheduling. Today, of course, as I mentioned, we'll talk about resource allocation, resource leveling, and those concepts which are resource-oriented scheduling concepts. Now, what is resource scheduling? Estimation of activity times and project durations using network diagrams, assuming that there is no cap or there is no constraint on the availability of resources. That is what we have been doing. If you will recall, there was an earlier example, we are probably going to do it again today, that we estimate the quantum of work, have a number for the productivity of the labor or equipment, and try to come up with the time that is required to complete that activity. So we almost assume that there is no constraint on the availability of the resources as such. But in real life projects, there are resource constraints such as shortage, delayed delivery, competing demands. It may happen that you may have a set of resources, but there are different activities in the project which demand the use of that resource. You may have only 10 laborers or 10 workers, and there may be 5 activities which demand labor or demand workers to complete them. We have to decide as construction managers which activities would take precedence over the others, and so on. So there are various situations because of which we need to do resource allocation. We have to decide or prioritize which activities will be taken up first, which may be postponed to a later time. Resource planning and allocation plays an important role in managing construction projects. Now let's look at the principles involved in deploying resources to activities in a project and the resulting implications through a very simple illustrative example. We have talked of this project before when we considered a simple project having just activities A, B, C, and D with precedences as given. A and B are independent and can be started right at the word go. C depends on A and D depends on B. This is the mandate requirement as far as each of these activities is concerned. Now, we also said that A and C require labor of similar expertise, let's say T1, and B and D require labor of another expertise, which is T2. What we tried to talk about was that if we allocate, let's say, 10 numbers of T1 expertise labor and 10 numbers of T2 expertise labor, how will the project planning be done? Now, once we assume that there are 10 workers with T1 expertise available to us, 10 workers of T2 expertise available to us, we can find out that the time required to complete this project is 50 days for activity A, 20 days for activity B, 30 days for C, and 20 days for B. This is nothing but this number here, which is divided by the number of laborers. Now, what this assumes is that the labor supply or the availability of labor, whether it is T1 or T2, is constant over the entire duration of the project. Representing this project on an activities and arrow network, we can find out that if A is done in 50 days, C is done in 30 days, B is done in 20 and 20, the earliest that the project can be completed is 80 days, because this path is now the critical path. This can be done in 40 days. In this representation, what we have assumed is that as far as the labor with T1 expertise is concerned, as far as the labor with T2 expertise is concerned, both of them are employed to the fullest extent right from the word go till the project is completed. So 10 numbers of workers with T1 expertise work from day 1 to day 80 when the project is completed. Initially, for some time, they work on activity A, and then they work on activity C. In this case, we have assumed that the activity B starts at the earliest that it can, and these people who have an expertise in T2 work initially on B and then on tea, and then everybody goes home. This part, of course, can actually be completed